All right, this is part 3 of 10.1, stem and leaf plots. How can I use stem and leaf plot to analyze data? Okay, cool. Once we have the stem and leaf plot, we want to actually analyze it and tell what it means. Say something about what it means. This stem and leaf plot shows student test scores. How many students scored less than 80 points? So that's our first part, part A. How many students scored less than 80 points? My highlighting is just stupendously awesome. And how many students scored at least 90 points? Students that scored at least 90 points. Remember with questions, I guess I do how many. Remember with questions, try to imagine what the answer would sound like or look like. If it's how many students, it should be a number of students, right? So first thing, I'm gonna organize my responses here for part A and part B. Okay, all right, now, before I even jump into looking at a stem and leaf plot, I should go to the key to determine what the stem and leaves represent. 9 vertical line 2 equals 92 points, which means the 9 in the stem must represent the what's place. It must represent the tens place. I forgot the apostrophe. Tens, and then the leaves must represent the ones. Why is that important? We want to know how many students scored less than 80 points. Well, this is cool because we have, if these are the 10s, 60, 70, 80, 90, and then 100, we only care about the 60s and the 70s. So 66, that's one student score. 70 is another student score. 75, 77, 78. So how many students is that total? That is 5 students. 5 students. Sorry. Okay. And I should say scored less than 80 points. I'm just gonna do, I'm gonna have to do this shorthand. Let's see, scored less than 80 points. Oh, this guy's got serious skills. Stem and leaf plots, I'm strong as an oak. A stem and leaf plot is one of in a forest of other data displays. All right, let's get to the root of the problem here. Okay, how many students scored at least 90 points? Wait, at least 90. I know less than, that's just the less than sign, but at least. If I have at least $10, that means what? At least. Oh. If I have at least $10, I could have $15, I could have $11, I could have 10, but that would be at the very least. So it must be greater than or equal to. So how many students have greater than or equal to 90 points? Well, we can just look at the 90s and the 100. So here's a 90. Is 90 greater than or equal to 90? Yes. How about 92? Greater than or equal to 90? Yep, 99 and 100. So that's 4 students. And then we can use scored, and then at least we'll replace that with greater than or equal to 90 points. Oh yeah! You can construct the blank set from a stem and leaf plot. You can construct the data set from a stem and leaf plot. 66, 70, 75, 77, 78, 81, 81, 83, 84, 84, 86, 88, 88, 89, 90, 92, 99, and 100. Remember to use the blank to determine the place value of the blank and the leaves. The key, the llave, the key to determine the place value of the blank and the leaves, the stem and the leaves. Let's keep going. How do I use a stem and leaf plot to determine the median or mode? Oh, that's cray-cray. I don't know how we find that. That seems like impossible. No, it's not. We can do it. Which statement is not true? Blech. Most of the, not true. Ugh. Most of the plants are less than 20 inches tall. The median plant height is 11 inches. The range of the plant heights is 35 inches. The plant height that occurs most often is 11 inches. You know what? I'm just going to have to make this data set so I can actually do this. All right, it's just a little too crazy trying to figure it out based off the stem and leaf plot. The key says 1 vertical line 5 is 15 inches. So 1 vertical line 5 is 15. So the stems, once again, are the 10s. And the leaves, once again, are the ones. Okay, 0, 1. So that must be good old-fashioned 1. 0, 2. Good old-fashioned 2. 0, 4. 4. 0, 5. 0, 6. Oh, looks like I'm just going 6, 8, and 9. Okay. 1, 0. Oh, this is the 10. So one group of 10s and 0, that's 10. Oh, I'm going to run out of space. I can already tell. 11. Can't do it. He's going to have to start writing thin here. 1, 5. Oh, man, the 5s are so hard to write. 17. Wow. He can do it. 22. Come on, come on, come on, come on. 25. Come on, he's going to fit it. 36. Oh, looks terrible. But you know what? It's good enough for rock and or roll. Okay, what does this first one say? Most of the plants are less than 20 inches tall. Well, actually, I don't even need my data set to see that. Do you see how many leaves are in the 0s and the 1s? So this statement's true because most of my data is less than 20. The median plant height is 11. Oh, I'm going to have to use my data set. So I'm going to do it like this. Put a little highlight, put a little highlight. Now 2 highlights, now 3 highlights on each side. 4 highlights on each side. 5 highlights on each side. 6 highlights on each side. 7 highlights on each side. Is that right? Do I have 7 on each side? Oh, I do! The median is the middle number when the data are from least to greatest. So the median is equal to 10. And hopefully you remember it's not as affected by outliers as the mean. Okay, so the median plant height is 11 inches. Is that true? Not true. It looks like B is the answer, but we're going to really make sure. And you're like, no, let's not. The range of the plant heights is 35 inches. How do you find the range? Isn't it greatest value minus the least value? Not the interquartile range, not the range between the quartiles, but the whole range, outliers and all. 36 minus 1, that's 35. Yep, that's true. The plant height that occurs most often is 11 inches. Wait, most often, isn't that the mode? Yes, 11 occurs twice, and no other data value occurs twice. So it looks like we have the right one. First, construct the data set, or as some teachers call it, data. What is the median of this stem and leaf plot? Median equals 10. What is the mode of this stem and leaf plot? The number that comes up the most often is 11. And hopefully you remember median and mode, measures of center. You are all amazing. You're fantastic. I hope that you continue to have a really good time, and at the roots of the rest of your day, you have a good time. And I hope that you hold out the olive branch of helping to other people who are not able to understand stem and leaf plots. Bye.